Hello again. As I record this video, I am just now uploading the previous one. This is the second video in my 2D Java game development log, where I just talk about my experiences and things I'm learning as I write this game, and potentially a few other ones in the future. So in the last video, I just went over what this project is, and I talked a bit about some of the bugs I've been having with it. And just as I was wrapping up the last video, I encountered a new bug I hadn't seen before. And in this video, I'm hoping to replicate it, perhaps. And if I can replicate it, I can. The first step to fixing a bug is figuring out what's happening, and I can't do that if I don't understand the bug. I think what happened here was that the all right um in this game we got a player, right? And you'll notice that relative to the window, the player is only moving up and down. The things that are moving left and right are the entities in the environment and the game level, but not the player themselves. They are staying um, in the same column of pixels on the monitor. So the way I'm doing that right now, oh, there it is. Okay, so that is the bug replicated. Um, and what happened there was I clipped into a block, the camera didn't follow me, and then when the camera didn't follow me, that caused the world to get pushed behind the camera, or the chunk I was in to get pushed behind the camera, and when that happened, the chunk was unloaded, it was removed from the level, causing the player to fall into the ground, and so they were, you know, removed from the game. That they, um, the game, they got a game over. So, uh, I think the way to fix this is to figure out how many pixels ahead of the, or behind the player, the camera is supposed to be, and then instead of moving the camera um, the same amount that the player moves, I'll just move the camera to that position behind the player. That could be... That's probably a safer solution anyway. So I need to figure out where this camera X is first set up. It looks like it's stored in the level. So camera X is declared right here. It's set to negative game width divided by 3. So game width um, is here. Width is passed to it by the constructor, which comes from here. Width is 1280. So okay. So that's where it should be when it starts off. And okay, so when the level is created, we create a new player, their coordinates is 0, 0. Then we allow them to drop from the top of the screen. That way they never clip into the terrain at the start. Um, okay, we're just initializing all the variables, doing all that stuff. And we're putting the camera exactly that position. Okay. So let's create a new variable. Let's call it private... actually, I'll put it right here. Camera offset. Call it that. And then we'll set it equal to, so instead of setting camera X here, we'll do camera offset equals that. And then camera x equals player.getX plus camera offset. And yeah, okay, I like that. So that way the offset could technically be positive, but it's negative, so it goes behind the player. That makes sense. Okay. And let's make a getter for the camera offset. So I'll go down here. Public int get camera offset, return camera offset. There we go. And so in the player class, instead of doing that, we'll do equals x plus level dot get camera offset. That should fix the bug. 5 minutes in, we might have already fixed it. I doubt it though. Okay, it looks so good so far. And I don't think there's any reason why that camera offset value should change at any point during the gameplay. So that should keep the camera a fixed position behind the player at all times. I really should have been doing that from the start, but instead I just moved the player. I just moved the camera at the same rate as the player, which, I mean, in practice, up until about 10-15 minutes ago, that had the same results as what we're watching right now. But apparently, with the changes I made in the last episode, that broke something. Yeah. Another thing I didn't think to show off in the last video was for debugging purposes, I added a key that could set the player's momentum, or not really momentum, more velocity along the or speed across the x-axis to 0 instantly. Ooh, that is a bug, and it's what I've seen before. Okay. That. I mentioned that bug in the last video, I think. Now, I still have all the old collision detection that worked. I know it worked. It's not collision detection. I keep calling it that. Collision detection is not here. It's in this method, and it's available to every. I'll remove that comment. I'm not doing that anyway. That's provided by this method, which we don't need. So that bug is coming back again. Okay. So what's... You know, why didn't I just take this collision detection that I know works and putting it... why didn't I just put it in here and then... Actually, so we'll put a comment ending here and one beginning here. Alright. And I could move this interpretation that I know works and doesn't have that bug. That bug we just saw there was what I thought I fixed like 2 weeks ago. And as soon as I switched which interpretation I was using, it came back, which means that this interpretation that I've got in the entity class has the bug. I know that now. So, I'll just copy paste this interpretation here. Control C, Control V, and then there are some things I need to do. So this code needs to go away. And all mentions of camera X need to go out of here. And also, from the last video, we decided that whenever we didn't move on a certain axis, we should set the movement on that to 0. So here, if in this block here, we're not moving on the x-axis, so we'll set x move to 0, even though we're not actually going to edit the x position anyway. So, like here, we're using x move on y or on x to move it, and here we're not, so the player's not going to move. But we're also going to set x move to 0, even though we're not actually using it, and it will get reset to 0 on the next tick anyway. Just to be safe, we're going to set it to 0 now. So here, we'll set y move to 0. And here, we'll set both 0. So x move equals 0, y move equals 0. And that should... I don't need this anymore. I used that forever ago. Let's check this. So now, again, we've got the robots and the player using the same collision interpretation. And so now the changes from the last episode that, one of the changes from the last episode where I made the momentum be carried over between ticks, but decreased if a collision was detected on that axis. That way, maybe if in cases where the player could have moved just not by that much, not by as much as they tried to on that tick, like let's say that their momentum wanted to move them by 0.5 tiles, but they were 0.2 blocks away from a tile, so they couldn't move the whole distance, but they could have moved 0.2 more. That way, if we preserve the momentum, but decrease it somewhat, we'll be able to, on the next tick, move a bit further, until eventually, a couple ticks later, we should be completely flush against the next tile. So let's make that change again. Pretty simple there. Every time we see a momentum value set to 0, we'll instead set it to x momentum times 0.5. And we need to set that to be a float, because multiplying by 0.5 apparently turns floats into doubles. That's just okay. X momentum times 5. Oh, actually, no, that shouldn't go here. We shouldn't do it that time, because this is part of the sliding mechanic. We shouldn't do that here. We should do it here though. So float x momentum times 0.5 and float y momentum times 0.5. And we won't do it here because this stops the player from going above the ceiling, which actually I don't think there's any real reason why they can't do that. I just decided against it, and there is going to be a jetpack power-up later on, and I think that's the idea why I added that there, so that the player can't go too high and not know, not know exactly how high up they are. I feel like the player should always know exactly where the player is. So I think I'm going to leave it in there for now. Maybe I'll modify it so that the player can go slightly above the screen. I don't know. Anyway, here's the game again. And my plan, just like last time, to see if my changes were applied correctly, is to go really fast, and hit walls at high speeds. And then but I need to do it while sliding instead of holding down the D key. So that way we can see if I slide into the wall or if I just have my velocity canceled out on the first tick where the collision was detected, and then me holding down the D key got me to move the rest of the way. Alright, looks like it's working. Alright, so that's that fixed, I guess. So as I mentioned last time, I want to keep these videos to be about 30 minutes long each. Last one was a longer one. I don't think it's even done uploading right now. I'll check once I'm done recording. So, what should I add next? I kind of want to add an ability to destroy the robots by jumping on them. Kind of like enemies in Sonic or Mario. Primarily, the controls and game mechanics of this game are kind of cloned from Sonic. But the procedurally generated stuff is from, I mean, it's meant to be kind of like Minecraft and Terraria. Yeah. All right. So I think let's do that thing with the enemies. All right. So in the, I think it's in only the entity, only the player class. We have a method called check entity collisions. So there it is, and it's a really short method. The way it works is we take the position new x and new y. That represents where the player will be on the next tick. And here we're going to use pretty much the same checks as from the block collision to see if the player will occupy the same space as an enemy in the next tick. And there are a few ways to handle this. If I recall correctly, the way it worked in Mario was if the player was moving downwards when the collision was triggered, that would result in the entity being destroyed. That's how I think it worked. I might be wrong. So, what I could do is I can add a method in the level class that will cause an entity to, or cause an enemy to be removed from this get enemies list. And when they get removed from that list, they will stop being ticked and rendered, and they won't have any effect on the game anymore. Effectively, they won't exist anymore. I'm not sure if they get completely purged from game memory. I hope they do. I think it depends on how I create them in the first place. So let's look into level, and okay, so yeah, so we're declaring a new enemy, and then we add it to the list, and then in the next tick we declare a new enemy called that. So I guess that should mean that this pointer is destroyed at the end of this method. So that means that the only remaining pointer to it would be in here. So we should be all good, I think. If I'm wrong about that, can someone tell me in the comments and tell me how I should be removing enemies? I do have a culling method down here where if there are more than 10 enemies in the game at the time, because in my playtesting, I found that generally the number of enemies that you actually encounter at a time is never really more than 5. Um, I figure if there's more than 10, then that's just silly, especially since most of them are probably not even gonna show up on the screen at that time. We'll just remove the first one in the list, which, if you know how I spotted enemies, that should be the one that's furthest to the left, or closest to the um, beginning of the level, um, or the one that should be behind the player. You see here that new enemies are spawned in as the player moves to the right, and they're always put a random distance through a chunk, but every chunk will we have a random number generator here, and each chunk has a 0.6% chance of having an enemy, and they'll only ever have one when they generate. They'll just generate with an enemy there. And so that means that you'll never see 2 enemies in the same chunk. You'll never see 2 enemies generate in the same chunk. They can move into a different chunk after they generate. So what I'll do next is we need to have a method to remove an enemy. So let's create that. Public void kill enemy e, and then we'll do enemies.remove e. There. That should be that simple. I'm pretty sure. Yeah, I have only like get enemies. Which actually, consider that as an array list, I should be able to just do. I think I should be able to just remove it, but I think it's easy to just do it from the level class. So, what we'll do is first, if so, there's 2 ways I can do this. If the player is higher than the enemy, we'll kill it, or I can make it so that if the player is moving downward, they'll kill it. But what I think is the best is if the player is above the enemy and they're moving downward. So if y y move, no, what, when is check entity collisions called? It's done after movement. Okay. Okay. That's good to know. So that means if we do if y move is greater than 0, so in my game, and I think this is typically what you'd see in 2D games, the y coordinates increase as you go down. So positive movements in the y-axis mean going downward. I know it's more intuitive to think that you'd go up, but think of it like words on a page. You're further in a book, you're further in a paper if you're moving down. So if y move is greater than 0 and new x is less than enemy dot, oh no, not new x, new y is less than enemy dot get y. So if that, then level dot kill enemy. Else, do the normal stuff. So what do I use the return of that for? Nothing. Okay. Okay, I just wanted to check that. I'm gonna have it keep returning true, just because, yeah, we did kill an enemy, but, you know, okay. So, let's see if that works. Alright, so we just have to find an enemy and, stomp on it, like a Mario. Oh, I... that seems to be working. There we go. Okay. So what I might do next, so the player can like jump, like bounce off of enemies, again, kind of like Mario. Um, we can have the player's Y movement get or Y momentum get inverted um, when that happens. So we'll do that, and then Y momentum equals negative Y momentum. So if they were moving down, they'll move up now. So you bounce off enemies. And then maybe I should also give enemies a death animation later. I haven't added enemy any. Oh, that worked. It worked. Okay. All right. So that's working as normal. All right. That that feels good. I like that. Um. So the way it works right now is if the player hits an enemy, um, they. Oh, I'm not sure if I liked that just now. Um, I was just barely above an enemy. Oh, and there again. I was just barely above an enemy, and I... Okay, I liked that, though. That's kind of fun. Okay, I'm not sure how I feel about that, because I don't like being just barely above an enemy to hit them. So, what I might do is perhaps the player has to be moving kind of fast. How did... that barely counted? Hold up. I need to check something. Okay, good. I was worried that gravity was counting there. It's not. Okay. So here's another thing we're gonna change. Um, so instead of new y, we're gonna do y plus height. That's what we're gonna do. Y plus height. And that way, I think the player should need to be sufficiently... Oh, now it's not working at all. Okay, let's go with... Instead of new y plus height, we'll do... Yeah, sorry, yeah, instead of y plus height, we'll do new y plus height. Let's check that. See, now it's too hard to hit them. So... maybe like plus half the height? See, like I don't want to be barely above them, you know? Because I think that just feels goofy. Like, I think that's actually how Mario works. I might be totally wrong. People who know way more about Mario than I do can... that feels better. I can't hit this guy. There we go. Alright. That feels better to me. Maybe I'll change some of the rules again later, but that feels better to me. And at the end of the day, it's all about making the game that is enjoyable, right? Uh, but with those changes done, I'm gonna call it done for this episode. Although it does look like the game is running a little slower, so maybe I'll have to optimize some of those changes in the next video. I'm not sure yet. Another thing is that I'm often hitting enemies by accident. Oh, one more change that should be really quick. If I hit an enemy, I kind of want to bounce off of it. So the enemy should bounce off of it, off of me. Or actually, these enemies are made of metal. Like, look at that, they're made of metal. Should they really be bouncing off of me? I think I should be bouncing off of them. I should be much lighter than them. There we go. I don't know, but I don't like look down here. The frame rate. It says it should be steady at 60 frames a second. It doesn't feel that way. I'm rambling again. I wanted to I wanted to be done. So all right, I'm gonna stop recording now. I'm gonna upload this video, and yeah, next one will be probably gonna make this like a weekly thing. Um, like maybe every Friday, every Wednesday, something like that. All right, so that's the second episode down. We fixed our collision bug, and we added some new features with the enemies. See you next time. Goodbye.